In this video, we'll learn how to solve inequalities, graph the solution set, and write the answer in interval notation. Inequalities in some ways do resemble equations. The big difference, of course, is that in the middle, where there's an equals sign for an equation, in inequalities we have an inequality. There are 5 different kinds of inequalities. We have the greater than or equal to, less than or equal to, not equal to. When we write the answer in interval notation and when we graph the solution set, the kind of inequality we have will tell us what kind of endpoints we have in our graphs and intervals. So for example, for the greater than, we'll use a parenthesis to exclude the endpoint. When we have a greater than or equal to, we'll use a bracket. Let's say we have the inequality x less than 2. There are a lot of solutions to this inequality. A solution is a number that you can put in for the variable that results in a true statement. For example, let's say we put in x equals 1. So if I put in 1 for x, we get a true statement. 1 is less than 2. So 1 is a solution to the inequality. Let's put in a couple of others. Let's say we put in 0 for x. 0 is less than 2, so 0 is a solution. Then maybe we could go to -2. -2 is less than 2, so we're seeing lots of solutions here, but not everything is a solution. For example, if we put in 3 for x, 3 is not less than 2, so 3 is not a solution. And 2 actually is also not a solution because 2 is not less than 2. So to keep track of these solutions, we draw the number line. And we note which numbers are not solutions. One is a solution, 0 is a solution, -2 is a solution, but we said that 3 and 2 are not. So anything to the left of 2 will be a solution. So to show the graph of that, we'll shade in the number line where we have solutions. We know that that goes all the way down to -infinity, so the way we capture that major feature is by putting an arrow going to the left like that. Down at the right end, we want to shade everything up to 2. So how far do we shade up to 2? Well, everything up until 2 is included, so except for 2. So what we need to do is use a parenthesis here to exclude the 2. So to clean up the graph a little bit, we can erase these. Like that. So we have a nice graph there. And to put that in interval notation, with interval notation we have two numbers, the left endpoint, the right endpoint. So the right endpoint is 2 with a parenthesis because we're excluding the 2. Since this is going all the way down to -infinity, we'll have a -infinity in there, and we always put a parenthesis around infinity like that. Now sometimes, in fact most of the time, the inequality will not come solved. The last example, it was already solved for us. In many of these, we'll have to solve the inequality before we can graph and write the answer in interval notation. So we have y plus 5 greater than or equal to 4. So we need to isolate the y first. So to do that, we do the opposite. So if it's y plus 5, the opposite of adding 5 is subtracting 5. So we have y greater than or equal to -1. So this is a solved inequality now. And what we'll do is we'll find a couple of points that solve it and a point that doesn't solve it. So we're looking for all the y values that are greater than or equal to -1. So if I put in, say, -2, is -2 greater than or equal to -1? No. So -2 is not a solution. So we'll put our 0, we'll put our -1, -2 is out. Let's try another point here. 0, is 0 greater than or equal to -1? Yes. So 0 does work. So we're going to start at -1 and we're going to shade to the right. So we see that numbers to the right of -1 are solutions. And since -1 is included, since we have the equal sign there, we use a bracket to include the endpoint. So for the final graph here, we can clean that up a little bit and leave this as our final graph. And then in interval notation, it will be from -1 to infinity, like that. And then sometimes we'll have even more work to do before we can graph and write the answer in interval notation. For example, here we have several steps before we can isolate x. So we follow steps very similar to solving equations. There are some important differences that we'll note here. So we begin by distributing. We break up those parentheses on both sides. Then we combine like terms. After we break up the parentheses, we can combine like terms. So the 6x and 4x give us a 10x. Then we'll bring the numbers to one side. So we'll add the 12 to both sides, doing the opposite again. We'll move the 12x to the left, so we subtract 12x. Now we need to get rid of the -2. So this is -2 times x. The opposite of multiplication is division, so we divide through by -2. But when we multiply or divide by a negative number, we have to flip the inequality. So this is all of the x that are greater than 3. So we have solved the inequality. Now we'll graph it and then write it in interval notation. So we draw the number line. We put 3 on the number line, and then we're going to shade everything to the right of 3, put in the arrow, and since it's a strict inequality without the equals sign, we'll use a parenthesis because 3 is not a solution. It's excluded. 3 is not greater than 3. So we have our graph, and then in interval notation, it's 3 to infinity.